This is part 14 of 8086 instruction set. We will see rotate instructions. The first instruction is rotate right. It rotates the destination operand towards the right, count number of times, with the bits coming out of LSB going into carry flag as well as to the MSB. Okay, so what you need to understand is if you have an operand like this, right, when you do ROR, that is rotate right, the LSB bit will be shifted out to carry flag, and that exact copy of the shifted out bit will be given back to fill up the vacant space appearing in MSB. Okay, so the shifted out bit from the LSB is copied into carry flag as well as to the MSB. That is how the rotation happens here. Okay, and this is the format of ROR instruction. We have only one operand specified here, that is the destination along with a count. The destination can be register or memory, can't be an immediate, and the count is either 1 or the value other than 1 is kept in the count register, that is the CL. Okay, now if you consider this example again, right, we have 1 in the carry flag and 0 in the LSB. Suppose that rotate ROR is issued again. So what happens is the 0 in the LSB goes into carry flag as well as to the MSB where a vacancy had occurred. Okay. Next instruction is rotate left. So it is exactly the same as rotate right, except that the direction is now left. Okay, so rotate left rotates the destination left by count number of times given in the instruction, with the bits coming out of the MSB going into carry flag as well as to the LSB. Okay, so if you consider this example, suppose this is our destination operand, and if you are issuing a rotate left, what happens is the bit in the MSB, which is 1 currently, will go into carry flag as well as a copy of it is taken and is used to fill up the vacant position in LSB. Okay, now consider this operand again, and suppose that we are issuing a rotate left. So what happens? The current MSB, which happens to be 0, goes into carry flag as well as a copy of it is reinserted into vacant space in LSB. So this is how rotate left works. This is the format of rotate left instruction. You specify destination and the count for the number of rotations to happen, and destination can be register or memory, and about the count, it can be either the immediate value 1 or for other values it can be kept in CL register. So what we saw earlier is rotate left and rotate right. So these instructions, they did a rotation with the shifted out bit going into carry flag as well as being used to fill up the vacant position. But now we are going to see a set of instructions which will actually rotate the bits through the carry flag in such a way that carry flag acts as an intermediate stop. Okay, so first is rotate through carry right. So it will rotate the destination right the count number of times, okay, with the bits coming out of the LSB going into carry flag, and whichever bit was there already in the carry flag, it will be used to fill up the MSB. Okay, so what essentially happens here is, if you consider this operand and if you issue RCR, suppose that carry flag is initially having a 0 bit initially. So the bit shifted out from the LSB, it will be taking up its place in carry flag, and the bit which was already there in carry flag, that is the bit 0, right, it will be used to fill up the vacant position in MSB. So it is like carry flag acting as an intermediate holder, and whatever was there in carry flag will be taken out and will be kept in the vacant position. Okay, so the format of RCR is this, right? We will specify destination and the count. Destination, as usual, should be a register or memory, and the count is either immediate value 1 or for other immediates it can be kept in CL register. Now we have another direction that is towards the left, that is rotate through carry left. So it is exactly the same as rotate through carry right, except that the direction is left. So it will rotate the destination left by count number of times, with bits coming out of MSB going into carry flag, and whichever bit was there in the carry flag will be going to fill up the vacant space created in LSB. So this is the structure of RCL instruction. We have a specification of destination and the count for rotation. Destination can be register or memory. This is an example of RCL. Suppose this is your operand and 0 is the arbitrary bit in carry flag. Now when you issue RCL, what happens is rotation will happen towards the left. So the MSB bit will be going and taking up its position in CF, and whatever was there in carry flag, right, that is the bit 0, it will be used to fill up the position that is created in LSB. Okay, so the MSB bit will shift to carry flag, and whatever was there in carry flag will shift to LSB. So this is how RCL works.